Picture your morning commute. Instead of sitting helplessly in bumper-to-bumper traffic, you're gliding past the gridlock on an electric scooter. It offers a massive amount of freedom compared to standard transit. But buying one of these online is a complete minefield. You will regularly see random, obscure brands offering $300 scooters that boldly promise a 50-mile-per-hour top speed. To hit that ultra-low price tag, those manufacturers are slapping together parts bin scraps with little to no safety testing. Best case scenario, the scooter breaks down in a week. Worst case, the cheap, unverified battery cells catch fire and burn your garage down. To navigate this market safely, you have to actively ignore the manufacturer marketing materials and focus entirely on the physical engineering. If you prioritize flashy numbers over tangible build quality, you guarantee that you are buying a dangerous, disposable toy rather than a reliable commuting vehicle. Manufacturers calculate maximum range using laboratory illusions, testing in the lowest power mode, crawling at 9 miles an hour with a 150-pound rider. Because you're heavier and ride faster, follow this rule. Cut the manufacturer's maximum range in half to find your real-world expected distance. The same physics applied to top speed. Once you factor in real-world tire friction and the mass of an adult rider, the actual GPS top speed of almost any scooter drops 3 to 10 miles an hour below the factory claims. You will also see motor output measured in watts. 1,000 watts is typical for a commuter, while 2,000 watts pushes into performance territory. But a higher wattage number does not automatically guarantee faster real-world acceleration because of how power is actually routed through the controller to the wheels. Because specification sheets are drafted in a vacuum, isolated from real-world friction and gravity, and mass, relying on them completely distorts your understanding of what a vehicle can safely do on the road. Building a scooter that can survive daily city use requires high-quality battery cells and durable metals. Integrating those materials introduces a strict baseline manufacturing cost that no brand can bypass. If you are an adult rider looking for a serious commuting tool, you need to skip the budget models entirely and enter the $1,000 tier. That buys you the stability needed to safely hold 25 miles per hour without the scooter wobbling or feeling dangerously underpowered. This $1,700 to $1,800 tier is the sweet spot, where you secure dual motor power and hydraulic suspension without the 100-pound bulk of high-performance models. Because it balances usable portability with enough speed to never feel slow, it's the specific price point where you finally stop feeling the need to upgrade. Putting more capital into the proper engineering tier up front keeps cash in your pocket later. It prevents rapid mechanical failures and endless replacement cycles, making cheap models expensive to maintain. When you're traveling over 20 miles an hour on tiny scooter wheels, an unexpected pothole can easily cause you to lose control. Adjustable hydraulic suspension is physically mandatory at those speeds to absorb that shock and keep the wheels planted firmly on the pavement. This vector breakdown compares stopping distances at 25 miles per hour. Drum brakes look clean aesthetically, but hydraulic disc brakes provide drastically shorter stopping times. That gives you the essential reaction time needed to stop when a car suddenly pulls out in front of you. Solid rubber tires exist, but tubeless pneumatic, or air-filled, tires offer significantly better vibration damping. Plus, they allow you to fix minor punctures in minutes using standard tire sealant. If you choose a scooter with tubed tires, look for a split rim design. It uses 2 distinct sets of bolts so you can separate the tire and rim completely from the motor, letting you perform your own internal tube repairs without specialized machinery. Surviving high-speed city traffic does not depend on the electronic output of your battery. It relies entirely on these specific mechanical hardware tolerances doing their job. Buyers often reject a scooter when they read it weighs 55 pounds, but the structural integrity required to carry an adult safely at speed physically demands a 40 to 80-pound vehicle. If a scooter is ultralight, the frame is likely too flimsy for daily abuse. Long-term ownership requires viewing the scooter as a maintainable vehicle, much like a mountain bike, that demands a regular commitment to upkeep. You have to adopt basic proactive mechanical skills. Checking the frame for loose bolts, tightening loose wiggles, and bleeding hydraulic brakes are mandatory tasks that you can easily learn from standard e-bike tutorials. By ignoring the marketing numbers, investing your budget in physical engineering, and embracing routine maintenance, you transform a risky online purchase into a reliable, permanent mode of transportation.